Hello guys, today going to give you some updates on these messy cables and certain things I've upgraded it. First off, let's go off the easier one. Okay, right now these two MPPT charger, these two, I have add in the ammeter, because I want to see both voltage and amps. And how the MPPT works and synchronize the two will synchronize, will find out each other power and charge the batteries. So I had this, they have internal ammeters. It's a little bit off, it's okay, it's totally usable. I just want to see them at one shot. I don't need to switch on it, switch the screens. So these are 50 to 100 amps AC ammeters. Actually I put them in line. It could work for DC, no issues. So right now you can see they are charging at 20 amps and both are the same, so they are in sync. Right now this one, the voltage seems off. As long as I cut off the inputs and reset it, it come back okay, but it does have the voltage run off. So this is not really concern for me. The more concern is how much power I'm getting in. That's the ammeter. Then I install it here before to see it clearly. This is the one additional. The other additionals is this. Let me see. This one, the screen is not doing well. Okay, reset it, because just now I reset it, this doesn't come back up. Okay, I have these contactors and manual cutoff to do these three grid tie inverters. So this is controlled by the Ewelink, which I have PLCs inside. That's the big one, the big changes. PLCs inside. So right now this is off. My system, basically I have two synchronized systems. This is on grid. There's a off grid inverters now I'm using. So now I have to go inside, show you guys. So this is the off grid now I'm using. Off grid is 3 kilowatts inverters. So that's the PLCs and installed, controlled by Ewelink. So this inverters also have one issue, is the cutoff voltage is too low. It goes up to 42, which is way too low, and it does, of course the two systems doesn't talk lah. This and that system doesn't talk. So instead of manually, I have to manually do it over the few months of testing the systems. So now I set up this PLCs. This is the charge discharge module XY CD 60. This one will monitor the lithium batteries voltage. So when I set this to cut off, there will be no power to the DC. Let me show you this. Okay, there's just two other modules. One is the voltage converter, so they convert the 48 volts or 50 something volts DC power for 12 volts that Ewelink 4-channel board. Okay, the 4-channel board will control two things. One, channel 1, I said that channel 1 is to control this off-grid inverters. Of course, just parallel it on the on-off switch. So this on-off switch now is off, but it's still working because I have a jump over through the Ewelink. So channel 1, once channel 1 is off, they are interlinked with channel 2. Channel 2 is that one. That is the contactors will cut off the AC to the grid tie inverters. So both interlink. Only one can switch on. Of course, I can control it in the Ewelink apps, or schedule it, or by time or what. that is one set of controls. Okay, that these two now works together. Is the second issue is about the voltage is solved by this one. So when this cuts off the electricity, the power to the power module, the Ewelink, of course, without power will offline. When it offline, all channels will be switched off. When it switch off, that means both systems will be off, and I go back to grid power. So the last part is this one. So now I switch it over. The normal source of power comes from my grid tie inverters. This one, off-grid inverters. This is the normal. So it's the yellow normal, because this ATS automatic transfer switch have normal priority. So whatever the system, whether if grid tie off-grid inverter is off, of course it go to the grid lah. So now this is the secondary become the grid. When the grid switch on, everything will be normal, whether the grid tie inverter switch on or switch off. This one, it doesn't care. Okay, it doesn't care. So right now the system is morning is about, I set it 9:30. Let the battery get a bit of charge. It will switch to the Ewelink apps will switch it to off-grid inverters until 2 p.m. 2 p.m. This is where the battery will get charged and it works. I will be off-grid, totally off-grid. So you can see totally off, zero, totally off-grid. Then after 2:30, 2:45, the Ewelink will switch it over to grid tie because the sun is getting set after that. Of course, there will be some sun, so to boost up all the voltage. So it will goes to grid tie inverters over the night, and up to about morning. It depends on the AC or the power consumption. If my battery is too low, this will cut it off. This will cut off all the grid tie or off-grid inverters. All will cut off, and I go back to the grid for maybe 1 hour, 30 minutes. It depends on the weather, because since the AC, it depends on air conditioner consumptions, how much. This depends on the weather, which will change throughout the seasons. So these are the few additionals. Then how I tie in generators. This is an off-grid from the off-grid cables. I wire in directly to the board. So I have this solar connector spare, so I use it one mark out as neutral, the other as live. So if in any case, which is I don't think I have any situation like this, the batteries is down, the weather doesn't support solar, and the grid is down, I could wire in this one from the generators. I have this one, the generator cables, one side. Let me put on one side which is this solar input. You can't get wrong, okay. Then the other side goes to the generators. This will tie in here, which override all system. I am not charging the batteries using my, no, I'm not. Then it goes into the normal source and goes to the house. So this is my generator tie-in, which is manual, because the situation is pretty rare. I don't think I'll be using these cables, but it's there for the design, because since I have connections over here, so the best tying point is here. It doesn't affect anything as long as unplugged. It doesn't affect anything. This is also ATS is normal. We'll set it to normal side. So the other thing, I don't think much will be done with this. I'm quite okay, and I have a charger which is controlled by Ewelink to charge the batteries. Not really charge the battery, to add certain power if the battery is too low. I will install a sensor board, battery voltage sensor board, to have some boost charge to the battery, not to get the battery too low. As I have certain situations running too low last time, where the grid time inverters and the cutoff voltage is not that accurate. Not that accurate. That is why I create this modules to the monitors here. And I just control one. The three grid inverters, all the three have different cutoff voltage. How I set it, there is still a variations. So I'm not depending on that one. That will be the secondary protection, which is like 1 volt lower than this one. But this one will definitely cut it off. But then, so I only calibrate one. This one will do. You know, I calibrate this one will do. Even you can see this is setting 55.6 and this is 56.7. So this is more accurate. This is not. But I'm depending on this one. Just one control everything. It's much more easier to control. So that's it lah. I just this one I'll add it in the controller. Some sensors, some module board lah. Where it gets too low in the early morning, very early morning, you will push charge on to maintain the battery voltage, so not to get too low and have some issues with the batteries. So it's quite messy. The cable is quite messy. Slowly I'll tie it in, or I might leave it like that. I'm not sure, because this is a DIY project. I might still be upgrading certain things. Some might be interested on why this one. This is the override lah. So even it's off or what, I can just come switch off the inverters. It goes to this one, then goes here. So this is the override. So other people might be asking, if my Wi-Fi is down, my Wi-Fi doesn't down. I have UPS. I created my own. This is previously this battery is previously from my UPS, 24 volts. So this powers my Wi-Fi router. So it doesn't down, never down, because my wife really needs. He works on at home. She works at home, so she need the Wi-Fi to be always up. And we now in Vietnam. We are in Vietnam, by the way. We do have some power disruptions. So this was done quite some time ago. So last time it was using just UPS to power the router, the power supply. So now UPS goes out. The UPS is too old, goes out, and I plug out the batteries. This 24, so I have a 24 to 12 volt converter. Additional heat sink switch and all that to reset the router. I just switch it on, no need to climb it up. Then it's not affected. This is the charger, but I want it to cycle the first top 10%. So this board will cycle the battery top 10%. I do not want it to be keep charged 100%, because who knows what will happen. So I let it cycle a bit, the top 10% only. Then I'm expecting 1,000, maybe 4,000, 5,000 cycles from this, which 10-20 years later. Then by that time I should be upgrading the system much more earlier than this. So beside this, some you might be interested in this one, fire protection. So this is the so-called fireball. I place it all above all these things. So instead of fire, I have this protected, and I have 2 fire extinguisher on the side. So should not be any issues. Okay, that's all. Thanks guys. It's a long video. Bye bye.